Hi everyone. Myself, Suresh, Assistant Professor from the Department of Electronics and Communication Engineering, St.JOSEPH'S Institute of Technology. Yeah, good evening. Today we are going to discuss about what is microprocessor and what are the importance of microprocessor and how the instructions are specified by the way of data and uh, program. So it's mean that we are going to depthly discuss about addressing modes of microprocessor, how the data will be specified by using the instructions. Yeah, let's we discuss about what is microprocessor initially. What is microprocessor? Yeah, generally we short formly use as MUP. Microprocessor is a program controlled semiconductor. Generally, we call it as an integrated circuit IC. So, what is the function of microprocessor? So, manipulation of the instructions. What is the meaning of manipulation? So, it's that fetching of the instructions and decoding the instructions and executing the instructions. So, generally, we call it as an the function of the processor, the manipulation. So fetching of the instruction, what we are going to do, the task will be manipulated with the help of instructions. Okay, fine. So we are going to discuss about instructions, how the instructions will be framed. And before that, what are the types of microprocessors are available from starting onwards 4-bit microprocessor. Right now we have an updated, very updated processors are there. Okay, so what type of microprocessor we are discussing in this session? The first thing will be discussed about 8086 16-bit microprocessor. Why dedicatedly we discussed about 8086? It is a pipelined architecture. So the speed of operation will be very higher and can able to do both 8-bit ALU operation as well as 16-bit ALU operation. So generally we preferable for the 16-bit. Okay, so we don't want to deviate to the topic about what architecture and other than that. We just discuss about addressing modes of 8086 processor. Okay, fine. Okay, before moving to that, first we should know about what is program. Yeah, because we should discuss about instruction, right? So before that, we should know what is program. What is program? We A set of instruction written to solve a problem, right? What is program? A set of instruction written to solve a program. So first find the problem, and we need to give a solution in terms of instruction. That means grouping of instructions will make it as a program. The program will helps to solve the task, any type of task we discuss. Then what is instruction? Okay, generally what is instructions? The direction which a microprocessor follows, it's mean that to execute a task, a part of a task. So the processor, we just given a direction to the processor to execute the task by step processor. Okay, so the instruction group of instructions will be call it as in a program. The program will help to execute the task. So dedicatedly we discuss about the program, how we are going to write the instructions and what type of instructions will be, right? So program is a set of instruction to solve this problem. The instruction will help to direct it. So how we are going to write an instructions, because everybody is a human, we have a language and we able to communicate with each other. So if you are going to communicate to humans, so based on the languages, that may be in the regional languages or the common languages, like that. Likewise, if you want to discuss about the machine, suppose you want to make the machine to work on it, so need to uh, given a command to the machine in the way of instructions. How we are going to given a command? So just write it in a program. The program will be as in a grouping of instruction. Repeatedly, I'm telling that. So how we are going to write in a program? So we have a separate languages, assembly language. So assembly language program, ALP we call it as an. So it will help you for understanding the machine and human. The human interaction will help using the ALP program, right? So what type of thing will we do that? So we just call it as an ALP that we used to the language ALP as an a code. the operator name and the instructions types will be generally we call it as an mnemonics, right? So the mnemonics is a word which helps the instruction in this language, ALP language. What type of instruction? The instruction in the languages in ALP is called as a mnemonics. So the mnemonics will represent, it may be in as a form of both alphabets and numbers. Okay, so that we are going to discuss it. And the same way, the assembly language, we just want to do it in the simulating manner. So software, we just go on a assembling section. That is a hardware will be part as an assembling, and the software will moving on to the assembler. Okay, fine. So efficient software development, which help us in ASM, that will help to execute the program in software manner. If suppose doing a very big large programs executions, we just move on it ASM to execute, and finally we download to that chip, and will execute the what kind of process you have decided, right? Based on the application. Fine. Okay, then what we move on it, right? So preferably we start with an don't want to go very large way, we just directly move on to the addressing mode, right? What is addressing mode of 8086? The way of representing the instructions, sorry, the way of representing the data by an instructions. What is that? Why I'm representing this? Sorry, that the data, or we call it as an operand, or we can say that it will represent the information in terms of data. So how we are going to define it? The way of representing the operand by an instructions is called as an addressing modes of processor. Okay, so what type of addressing modes are available? Many types of addressing modes are available. That means that many way to represent the data by an instruction. Okay, so we have a standard set of addressing modes are available. So generally we call it as an AM. So I just want to say that the first one will be addressing mode. I'm going to grouping it in the 8086 5 category. So this is a grouping 1. Okay, grouping 1. So grouping 1 will be one of the criteria, and then grouping 2 is another criteria, and third as in a grouping 3, and fourth will be as in a grouping 4, and fifth category as a grouping of 5. What is grouping? So some type of where data representations like in a memory or immediate or indexed way. So different type of category we are going to show it on a data. So in that, first will be represent the addressing modes. The grouping number 1, the register and immediate. Register and immediate. Okay, two different types of representation will be under immediate addressing modes. So two different types of data transforming with the help of grouping 1, register. So it's mean that some type of addressing modes under the register and immediate. Second category will be the data transfers are accessing the data in terms of from memory. Okay, memory addressing modes. So it will be as a register and immediate, and this will be as a memory data addressing. The third will be input output. Okay, so input or output data accessing. Okay, input or output data accessing. Then relative type of addressing modes. Okay, relative type of addressing mode, and the last one will be as an implied. So generally the data will be presented in the what? Instruction itself. Okay, so first I started with an addressing mode. The addressing mode is the way of representing data by an instruction, and under the addressing mode we just use an ALP language. The ALP language represent the instruction is in the mnemonics, and in the mnemonics we going to say the different way of addressing modes are available. The first one will be a grouping 1, register and immediate, and second will be grouping 2, memory data, and third will be as an IO data, and fourth will be as a relative addressing mode, and fifth will be implied addressing mode. Okay, so 5 different category of an addressing modes are available, right? So if we are going to discuss in the register addressing mode, the first will be register type. Okay, under the register type, we just call it as in a register addressing mode, and here immediate addressing mode. Okay, register addressing mode and immediate addressing mode. Okay. Right. Okay. So what type of register addressing mode in that? What type of register addressing mode? So generally first we should know about the syntax of any instructions. So how it will be represented. Okay, the first will be as an operator, and second will be as an source and a destination, and it will be in a source. Okay, so this is operator and destination and source. So mean that what type of function we are going to perform here, and where you are going to keep your data, and which locations are you going to locations are any of the registers or any of the immediate will be. So we go into this is syntax operator, source and destination format, right? The first one, register addressing mode. What is a register addressing mode? So I just going with an example of moving of data. So I just use that move mov, right? So mov, and this is the operator, and the instruction will be, we have different types of conditions. If you are going to transfer the data, the source and destination may be a register, or source and destination, one should be as an immediate data and another will be destination, and another cases it may be both will cannot be in a memory locations. Okay, so we'll discuss later on. So first will be register. So mean that I just go on it. In everybody know that in 8086 we have different general purpose registers, and registers we have an AX register, BX register, CX register, and DX registers. We have keep many registers along with some segment registers. Many things will be there. So in that, for I just go and, for example, I'm moving on a 8-bit. I just use it here C register and here D registers. Okay. So what it mean that, so two registers will be taken at two registers, C register with the low, D register with the low. So low means each and every register is a 16-bit register, and in the 16-bit registers, we can use it as a lower and higher. So lower contains 8-bit and higher contains totally 16-bit. So this instructions represent one 8-bit data will making from one register, moving from one register to another register. So CL to DL, right? So what this will be represent, the CL is a count registers or carry registers, and D will be data registers. So it having 8-bit value, and it have to keep 8-bit data where you are taken from that another register, right? So this is one of the example for register addressing mode. How we are going to call it? First define it. So the register itself having a data. Okay, this is a definition for register addressing mode. The register itself having a data. It means that the part of instruction having a data. The way of representing data by an instruction. Any way you can represent it. So DL register having a data, that data will be moving to the CL register. So this is a register addressing mode. Okay, fine. If suppose we are moving to the 16-bit value, so you just change the CL will be CX and DL will be DX, right? It can able to do it, right? So this is a register addressing mode example. Then come to the indirect, means the immediate addressing mode. So what it means that immediate addressing mode, the same. I just taken it move, and here I just go on it sum of registers AX accumulator register I'm taken it, and comma, right, AX, and the source registers will be source will be immediate. So it should be any of number. Okay, for example, I just 02. If I'm using 02, which hexadecimal representation? It actual meaning is 02 is called as a 0002, right? So either you can use it 02. This cannot be used. It cannot be. You can use either AL or AX. AL it's help or it's enough for keeping 02. AX if you are using, you just represent 002. So the same instruction will be 8-bit and 16-bit will be AL comma 02H. So what is the meaning of this one? This is an immediate addressing mode. How we are going to define it? The source having the data immediately. How we are going to define it? The source. It means the instructions having data immediately. The data representing immediately by an instruction. So this is a representation of immediate addressing mode. This comes under register and immediate grouping. Grouping number 1. So first grouping, register and immediate. So register and immediate, two category, register and immediate. Register will be the first one and immediate will be the second category. Okay, fine. Then come to the next one. Okay, come to the next one. So in that, this is the first one, and second one, memory. So how we are going to say that? What is memory? The location carry or the location holding or location storing, that kind will be called as a memory. So it will be in a 16-bit. Always the memory location should be in the 16-bit, because the microprocessor have 16-bit data bus and 20-bit address bus. So 16-bit sends 2 power 16, 64K, and 20 will be 2 power 20, 1 MB. So that much of memory locations we are having it, right? So this 1 MB can be used it two different way, hard and even bank, and that will be different story, right? So here we are going to use it. So what I'm trying to say is, okay, what I'm going to do it, then memory data. So memory, we have an example of move. Again, I'm taking many things will be data transfer will help you. That is what saying that the data transfer, because discussion about how we are going to access it, right? So move. So what is move? Move memory location, right? So I just taken it one of the registers, index register SI comma, and will represent within the bracket 4200. I just taken small example. Okay, so if I written as move si comma 4200 will h, no issue on that. It will be represented as a 16-bit data. But what actually is saying that move si comma bracket 4200, what it mean that? So move is the operator and si is the source index as a registers, destination registers, and this will be representation of memory. Okay, because the memory addressing mode. So how we are going to define it? The data represented by an memory location, not by an register, not by an immediate. Okay, so the memory locations hold my data. That means that part of instruction hold my data. The part of instructions having a memory location. So suppose I want to take 02. Okay, 0002. Okay, 0002. So what if that 16-bit data should put it in the 16-bit registers. One 16-bit registers can hold 8-bit. So two different two locations needed for 16-bit data. So move si comma 4200. The 4200 is the memory location. What is the meaning of 4200? Along with the bracket. That bracket represents pointing the address. This is a very important crucial thing. The square bracket will represent. Suppose instead of square bracket, if I'm going to, then we call it as a data, right? So the memory location, the address hold the data. That data will move to the SI index. That means SI register, source index register. So if you are moving to many data, array of data, we just move on it SI. Okay. So what are the another instructions? Instead of SI, we can use it DI. So many things we have for memory locations. But there is no possibility of move si comma si or move si comma di or di comma si. The same way, move square bracket of 4100 comma square bracket of 4200. It's not like that. So both registers or both memory location could not. Both registers may be have, right? But both syntax registers should not be there, right? Same way, both memory location could not be. Okay, so these are all the very important thing to be understand. Then come to the grouping of memory. We have many things. This will be represent directly, right? The location will be mentioned here, so directly. Suppose I don't want memory location directly, I want to hide somewhere. How to write it? This is direct memory addressing mode. The second will be as register indirect addressing mode or register addressing mode. Already we discussed, right? This is a register indirect addressing mode. What is that register indirect addressing mode? The register indirect addressing mode says that the same move si comma something will be represent in the register. If you want to say that memory locations like move, it's not that improving. It's mean that to be the this will be covers the register. This register holding the data. That data will be moving to that. That means that the data will be represented by an register indirectly. That is the calling of register in indirect addressing mode. Okay. Then what about the next thing? Any type of register, indirect registers or some registers using the bank with the help of index registers, SIDI, and suppose segment related registers, data segment, stack segment, extra segment, many things will be, right? So that kind of thing will come over. And come to the next one, IO. What is input output addressing mode? The input output addressing mode is basically how you are going to access input data, how you are going to access output. What is that? Suppose if two humans will be there, direct communication will be made. If one machine and a human will be there, that particular language will be learned and both will be communicated with the help of that command. Suppose you are going to use in a machine, the communication, in between interfacing to be needed. That interfacing will be helpful to mediate the instruction to be transferred from machine to human, human to machine. So that interfacing with help of two different type of instructions, that is called as IO, input and output. So how we are going to represent in that? Input or output. So one will be represented in any type of, for example, AL, 02. Okay, 02H, you can use it, or out 02, AL, anything to be used it. So it's mean that the AL accumulator point the address, not the data. The out will be represent, you just taken it as not necessary to put in a square bracket, only for the direct we can use it. Otherwise it will be understandable. Instead, if you want to remove it, no problem at all. This will be the correct one as per the mnemonics. So you can use it for it. So input addressing mode and output addressing mode, basically what it means that this will be call and data for the input, and that means getting from the input, and this will be for outing. So we all know that input device, output device. Input will be some keyboard, mouse, like that. For output, we can use it as printers, scanners, many things will be have. Not only for that, any parallel communication, serial communication, use art, many things will be that. Memory accessing, pick, many things, right? Then come to the relative addressing mode. So what it indicated in the relative addressing mode? The name itself having the relative. That means just going to find where you are going to call or where you are getting from the call. So relative sense, our address will point somewhere, that will be make it as in a different case, like looping. Okay, looping. So if suppose you are going to make motor to be rotate, so first I need to represent how many data you needed. So for example, I'm going to rotate stepper motor, 4 different data will be needed. It's our convent for the lookup table. So the winding should be rotate step by step. If you're going to very faster manner, 1 or 2 by will be there, or if you're going to make it as in a step by step, will be 90-degree, A, B, C, D, like A1, A2, B1, B2. Likewise, you are going to make it a winding in the clockwise direction or anti-clockwise. So for that, we are going to keep on some data. So initially the program will be continuous for making how long you are going to do it, how fast you are going to do it. The how long will be represented using the array, and how fast will be measured in the lookup table. So from the regular program, you just discontinue it and move to the particular loop, and from the loop, you just call it one by one the opcode. The opcode based, we are going to make in a rotate of the stepper motor in the clockwise as well as anti-clockwise. So based on that discontinuity will call it as in some no operation will be needed. During this period, the continue program will be jumped to one location and call back it. So jump, that kind of program, compare, that kind of thing, and calling, looping, that kind of instruction. Many type of instructions for calling of the data, that comes under relative addressing mode. So for example, move SI, 1500. So this is a direct addressing mode. Move SI, 1500. Instead of 1500, I just write it as an AX or BX. So register indirect. So along with the AX or BX plus some indexed register, it will be represented indexed relative type, or JC, JNC, JZ, JNZ, JB, JNB, many things. Jump carry, jump. It means that suppose I'm going to do an addition operation. Okay, addition operation, two minimum data is needed. One is ardent and another one is argent. If I'm doing add and addition, what type of result will come? Either the result will be with carry or without carry. If suppose I have a with carry, I need two location. One some result and another one will be carry result. Two different location will be added. So once I'm added it, I just pass the result directly to the storing location if there is no carry. If suppose I have a carry, I need to add the data with the regular result, and the extra bit of value more than the 8 bit or 16 bit, that will be stored in another location with the help of looping. JC, JNC. It will be ensured to check it and execute it, and once it will be incremented by CX or some other registers, after move to the register. So this kind of discontinuity will be help to call where you are going to store and where going to take it. This process is called as a relative addressing mode. So what type of instructions comes under in this? Jump carry or jump no carry, jump borrow, jump no borrow, or if you are going to compare, that will help you use it. And any of relating call, like usually we are using the label, loop label likewise. Okay, then come to the implied addressing mode. So we have a many different of relatives is there, and under in this we have many types of direct, indirect, many thing will be, but this is a standard one where you are going to. Next come to the implied addressing mode. What is implied? So generally we call it as an implied, since the name itself having, in that instructions, there is no representation of operand and output. So only the operator will be there. The operator itself can define what going to do it. That means processor controlled instructions comes under the implied addressing mode. For example, I just move on to HLT. This is a very important instruction in the processor. Halt the program, terminate the program, stop the program. Once the task will be completed, this is a final instruction to keep at the end of the program. It helps to terminate your program, right? So what it mean that? Okay, what it mean that? So just look on it. This is syntax. Already I told you, there is no destination, there is no source in this instruction. Only we have an operator. So HLT. So if the instruction will be executed in the processor, it will be terminated. It will be reset to the end cases. So this instruction itself, the processor have or define it and control the program. So this type of implied, not only HLT, many instructions available in this kind of processors case. So we can use it like a relative, a call, absolute call. So many call by reference, call by value in C type, the same way here also. So we have a different category of addressing mode. Why we are studying this one? This is what I'm initially say, that now you may able to understand what I'm trying to say. I hope you can understand what type of this means. The processor can understand, the user can understand how the data will be called for it. I just want to represent my data immediately by using instruction, part of instruction having immediately. The another way, if you want to represent my data instruction, so with the help of registers, I can represent the registers in the source position to show it, the data will be presented in the instructions. That means representing data accessing. Because the way of accessing the data by in instruction is called as an addressing mode, right? The third will be memory. Memory location will help on it. Already I told you that 2 power 16, 2 power 20, the 2 power 20 will be the program. Okay, that means program will be help it is memory location 1 MB. But 1 MB will be having a separate different criteria, because directly we are not able to access it. We just with the help of the segment register, because the physical address finding in that will be different case. Okay, physical address is called as a memory address. If you want to access the data, it's a very big process, but it will be very faster in the process, because the name itself having the microseconds, it will be do that. Okay, so memory locations will be taken it, and next will be the IO, input and output category. So input type of accessing and output type of accessing. any type of data with the help of communicate between peripheral device and user. Okay, if you are going to communicate, if I'm going to press some key in the keyboard, how it will be recognized in the processor. So that key will be have an opcode. That opcode will be fetched by the CFR, and that will be help in that mnemonics. That instruction will be represented in that instructions INAL comma 02, INAL comma 05. That 0 IAL will be registers, destination registers, and shows the address. The 0204 will be the pointing the address, and relative any type of condition based or unconditional based jumping or calling or different types of referencing. So this kind of even we have an instruction like logical instruction swapping, many things will be right. And implied addressing processor controlled type of instructions will be calls under will be okay, comes under in the implied addressing mode. So very important and crucial role of addressing mode is in the microprocessor, because the human may be interact directly, but if machine language we should know about the program and instructions and followed by what type of programs ALP, and in that what type of languages they are using it and how the machines will be working it, what are the types of it. Because this microprocessor is a 16-bit processor. It have two different units. One is bus interface unit and execution unit. So bus interface unit can do communication between each and every category present over the architecture, and execution unit only that. It means that it will be the fetching, and here will be decoding and executing. This what already I told, that processor is a programmed controlled semiconductor. It's an IC. The function is fetching of an instruction, decoding of the instruction, and executing. This process is called as pipeline architecture case. Okay, so we if you want to discuss more about the processor 8086 processor, we just discuss with the next type of videos, right? Okay, next type of videos, and in that videos I can able to elaborate the pin diagrams and architectures and interrupt how it will be communicated with each others, and uh, yeah, some of the assembler techniques. And apart from that small program how we are going to write it, like addition, subtraction, multiplication, division, some of copying of things, and manipulations of some code conversions, many things can do it. And especially 8086 processor is a very good processor compared to that 8085. It will correctly do it, because in 8085 if you are going to do 16-bit we just go on a double addition, but in that case direct instructions will be available. So many things will be suitable in that, so no need to worry about to learn about this. There's a very prerequisite, I just minimum informations I given to you. I hope that this session will be clear to you. Any doubts in that you can refer it, you can ask, I will clear it. I hope this session will given a minimum of interest comes in that microprocessor subject. Okay, thank you.